Let's take a look at 9.2, special right triangles. In this lesson, we're going to take a look at two triangles in particular, 45, 45, 90, and 30, 60, 90. What do those numbers mean? Well, those are the interior angles of those triangles, and we'll show you what makes them special. Before we get to that, we have right here isosceles triangle. We'll talk about, an isosceles triangle. What is it? Remember, two sides are congruent, or the legs, right? So it's a triangle where you have two legs that happen to be congruent. Let's go ahead and move on. So right here, the first theorem is this 45, 45, 90 triangle. And this is a special right triangle. And the thing right here is this, is that, remember, because the legs or the angles happen to be congruent, two of them, the sides opposite of the legs are congruent as well. Okay? Because remember, the size of the angle will dictate the length of the opposite side. So if both of those angles are the same or congruent, then that means the opposites are going to be, the opposite sides will be congruent as well. Therefore, it's x and x. Opposite of the 90-degree side will always be x times square root of 2. Okay, now remember, this is only for a 45, 45, 90 triangle. Or I'll eventually just start saying 45, 45, 90. And so whatever the leg is, square root of 2, that'll end up equaling the hypotenuse. And it's important to remember this equation because sometimes they may give you the hypotenuse and you have to find the leg. So then you just have to plug in the numbers accordingly and solve for x instead. So that right there is your 45, 45, 90. As we move along right here and take a look at the next special right triangle, we have 30, 60, 90. And it says in a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg. And then the longer leg is rad 3 times as long as the shorter leg. So the leg, the shortest one, we'll just say is x. The hypotenuse is equal to 2x, or short leg times 2. The longer leg ends up being equal to short leg times rad 3. So you do need to make sure you know all of these right here. And hypotenuse, we could usually, we'll simplify it as 2x, as you could see on the diagram. And then for the short leg, we always put x rad 3. And typically, this is how I'll write things out. I'll put 30, 60, 90, and an easy way to memorize this, 30 is I put underneath as x. With the 60, it's going to be x rad 3, and then 90, I put 2x. Okay, so I'll usually always write that down to help me remember things, especially when you go through a problem. Or you could see right there what's highlighted. That works too. But bottom line, opposite of 30 is x, opposite of 60 is x rad 3, opposite of 90, 2x. If we go back right here to 45, 45, 90, I'll do the same thing. 45, 45, 90, and then we have x, x, x rad 2 as the side lengths for a 45, 45, 90 right triangle. Okay, so what I just boxed off right here, make sure that you have both of those down, and it'll be very helpful when you're trying to get your answers. Okay, you got to think, well, what sides do they give me? Are they giving me the long leg? Are they giving me the short leg? Maybe they give you the hypotenuse. And so if they give you the hypotenuse, well, you're most likely going to have to figure out the long leg and the short leg. If they give you the long leg, especially in a 30, 60, 90 right triangle, you might have to find the hypotenuse and the length of the leg. And you're going to use these equations that's highlighted right here to help you achieve and get those answers. All right. So let's try to put all of this into practice right here. and take a look at number 1. Okay, so it says find the value of x. First off, let's figure out, well, what type of a triangle do we have? I see 90. I've got right here 45. Well, that means that this missing angle right here has to be 45 degrees as well. So remember, we talked about how does this work? We got 45, 45, 90 right triangle. And in that instance right here, remember, opposite of 45 is x, and opposite of 90, x rad 2. I look across some information right here. Opposite of 45, we have the side that's 10. So what that tells me right here is that the leg is equal to 10, or which happens to be x. So if I want to find the hypotenuse now, all I need to use is, or the hypotenuse is equal to x rad 2. I know what the leg is. Remember, the leg happens to be x as well. And so your hypotenuse is equal to 10 rad 2. And there you go. Write your answer in simplest form. Remember, what do they mean by simplest form? Make sure that you have it in simplest radical form. No decimal answers. Okay, so that right there is important. And we just went ahead and found our answer. Just like that. Okay. Let's go to number 2. So on number 2 right here, it looks like they give us another 45, 45, 90 right triangle. How do I know? Take a look. I've got 2 sides that are congruent, or the 2 legs, right? Because this is an isosceles triangle. So remember, in order for the 2 legs to be congruent, these other 2 angles have to be 45 and 45. Because we have a 90, we already know one of the angles being 90. So we know what the leg is, all right? So fantastic. X, which is equal to the leg right here, is equal to rad 2 over 2. So the question now is, well, let's find the hypotenuse. So remember, we have the equation, and the hypotenuse is equal to x rad 2. Well, since they give us the leg, what I'm going to go ahead and do now is take the leg, we'll substitute that in for x, and then figure out our hypotenuse. Okay. When it comes to dealing with multiplying fractions, you multiply straight across. So we have rad 2 times rad 2, which is rad 4. And rad 4 is equal to 2. So 2 over 2, and then we end up with 1. So x right here, which happens to be our hypotenuse, that equals 1. All right. Let's go to number 3 next. Okay. This time, I know once again that we have ourselves a 45, 45, 90. I've got 2 legs that are congruent. But this time they give you the hypotenuse. Remember, the hypotenuse is equal to x rad 2. So what I'm trying to find are the legs. Right? So let's once again, we go to our equation. Right? Hypotenuse is equal to x rad 2. But this time, since they gave us a hypotenuse, I will plug that 8 rad 2 in for the hypotenuse section and set it equal to x rad 2. All right. So we'll go ahead and divide both sides by rad 2. And x ends up equaling 8. And there you go with number 3. Just when you think, hey, we've gone over plenty of examples right here, there's one more twist that they like to throw at. Let's take a look at number 4. So number 4 is pretty close, or is pretty similar to number 3. Remember, we have 45, 45, 90. And then since they gave us the hypotenuse, we've got ourselves, we'll use this equation, and I'll plug in 12 in for hypotenuse. Okay. Now this time we got to go ahead and divide both sides by rad 2. And so x is equal to 12 over rad 2. All right. Now, the question says write your answer in simplest form. If you remember, maybe from Algebra 1, you should have learned that you cannot have a radical in the denominator. Okay, once again, you cannot have a radical in the denominator. So what we're going to do next is this step, what we call rationalize the denominator. I'll go ahead and write that down. But when you rationalize the denominator, and maybe you want to look it up, you might want to Google it. I'll go over it real quick, but if you need more examples, hit me up during tutorial. Right here, in order for me to get rid of the rad 2, what I'm going to do is multiply top and bottom by rad 2. Because if you took a look like on number 3, when we have the same thing, or actually it was number 2, when I took rad 2 times rad 2, it got rid of the radical and it became 2. Because rad 2 times rad 2 is rad 4. So right here, the same thing will happen. Rad 2 times rad 2 will end up equaling rad 4, which equals 2. And then I'll have 2 over 2 times, or sorry, 12 times rad 2 over 2 right here. And then I can take it one step further because this 12 and 2, I could go ahead and divide, and I'm left with 6 rad 2. And that equals x. This skill right here is absolutely critical in order for you to be successful in Algebra 2 and also right now in this chapter. All right? So this part right here is rationalize the denominator. You might need to look it up. All right? Or come to tutorial, I'll go over it some more, or make sure you guys ask in class. All right, so this part right here, absolutely important. Once again, what did we do right there? That became 12 rad 2 over rad 4, right? And that rad 4 became my new denominator of 2. All right, let's go ahead and move on. Well, look at number 5. This looks like we have a 30, 60, 90 special right triangle. Okay, we got 90 degrees. One of the angles is 30, so that missing one has to be 60, right? Because the interior angles of a triangle have to equal 180. And so now it all works. Okay, let me go ahead. We start off 30, 60, 90. And side opposite of 30 is x. The side opposite 60 is x rad 3. And side opposite of 90, which is the hypotenuse, is equal to 2x. So we have short leg, long leg, hypotenuse. Okay, that's the way I think of 30, 60, 90. Short leg, long leg, hypotenuse. So if I look right here, they actually give me the short leg. That makes things so much easier right now because then I know that right here, x ends up equaling 15. Right? Well, that's how long the leg is, right? The short leg. So I'll go ahead right here. Actually, let me go back. And I'll go ahead and substitute 15 right there. Well, what about the long leg? Well, the long leg is the leg times square root of 3. So we'll go ahead right here. 15 times rad 3. For the hypotenuse, remember, you take 2x, right? 2 times the short leg. The short leg is 15. 2 times 15 is equal to 30. And we have now found, or this right here is supposed to be x. That's the long leg. And y ends up being the hypotenuse. And if you look at, the numbers, the short leg should be the smallest number. And then it goes all the way up to the hypotenuse, which should be the longest side. All right? And there you go right there. If I figure out what x is, then what I end up doing is I just substitute and plug that in to different parts of the equation, and you get your answer. Okay. Let's see what we could do right here with number 6. Okay, number 6, a little bit different. We have 30, 60, 90, and I have x, once again, x rad 3, 2x. Now, based on the information here, they gave me the hypotenuse is 22. Remember, hypotenuse is equal to x times 2, or short leg times 2. So what I'm going to go ahead and do right here is I'm going to take 22, right, the equation, and then set that equal and figure out what x is, the short leg. So right here, divide both sides by 2, and x is equal to 11. Okay, so now what that tells me is that's actually the value for y, right? Because that's going to be the short leg. Well, we found out right here, and remember, this x represents short leg. Okay, so we have the short leg, which is actually y, but normally in the equation we use it as x, but we found y. So y is equal to 11. I'll put that right there on the side. And then, in order for us to find the long leg, remember, long leg is equal to x rad 3. We take the value of x that we just learned, which was 11, and I'm going to go ahead and substitute that in, and I got 11 rad 3, and that equals your long leg. Can't simplify it any further, so leave it at that. So now what does that mean? X is equal to 11 rad 3. And those right there are your 2 answers. All right. So I think right there, that kind of get us most of it. Well, let's try number 7. We'll practice a little bit more rationalizing the denominator. And let's go ahead and do this right here. So we have, once again, 30, 60, 90, x, x rad 3, 2x. Gotta memorize this. So what we have here is side opposite of 9, or angle opposite of 9, is the 60 degree. So 9 is the long leg. So what I'm going to go ahead right here, remember we got long leg is equal to x rad 3. The long leg is 9, and so we got to find x now. In order for us to do that, we're going to go ahead and divide both sides by rad 3. Uh-oh, we have a problem. I've got my radical in the denominator. So we have to rationalize that. In order to rationalize it, the easiest way is go ahead, we'll multiply top and bottom by that same radical, rad 3. Square root of 3 times square root of 3 equals square root of 9, which equals 3. So hopefully now you begin to see the pattern on how this works right here, and that ends up being the short leg, or the leg itself, which happens to be x, right? So it matches up this time. So we found what the short leg is. So now finally, the hypotenuse, we'll do the last part. Your hypotenuse is equal to 2 times the short leg. Well, we got 2 times, and then we'll substitute in right here. 9 rad 3 over 3. Remember, once again, we multiply straight across when it comes to these types of problems. And, oh, actually, let's go back one step. This, for our short leg, we could actually simplify this further, because I could take 9 divided by 3 right here. That part equals 3. So actually, x ends up equaling 3 rad 3. Okay? So there's our actual answer. And that makes things a little bit easier right here for our hypotenuse. Okay? So now let's find the hypotenuse. It's going to be 2 times 3 rad 3. And now we can go ahead and multiply 2 times the 3 that's on the outside. And we have 6 rad 3. And there's your hypotenuse, which ends up equaling what y is. Now we've got all the answers right here. All right. So the key thing right here is making sure you remember 30, 60, 90, 45, 45, 90. How long are those sides supposed to be? And so we got x rad 2 for 45, 45, 90. X rad 3, 2x are the sides for a 30, 60, 90. The sooner you can remember that, the faster you will be at this, and the quicker you'll be able to excel in this section. Let's take a look at number 8 next. We've got some very good word problems here. It says, starts off, sketch the figure that is described, find the indicated length, and then round the decimals to the nearest tenth. All right, so it looks like right here, it says we have ourselves a square. Okay, we'll start off, we've got ourselves a square. The length of the diagonal in a square is 32 inches. So I'm going to go ahead right here, draw a diagonal line, and what we do know is that this is 32. Now remember, in a square, there's some other things that we should be understanding of, is that we've got ourselves four right angles. Okay. What do the diagonals do to the angles right here? This is where everything we learned, or part of what we learned in chapter 8 comes in handy, is that it bisects it. So what do we have? We've got a 45, 45, 90 triangle right there. So now the next thing says, all right, let's find the perimeter. But then that means we have to find the lengths, right? So how do I find the lengths? Well, if I have a 45, 45, 90, this is how we put everything together. Remember, it's x rad 2. So they gave us the hypotenuse on this one. We have 32 is equal to x rad 2. And then we go ahead and find the length of the leg. Okay, so we'll divide both sides by rad 2. All right, and then unfortunately right here we do have to rationalize the denominator. So I got rad 2 times rad 2. And so we got 32 rad 2 over 2, and that is equal to x. We could simplify this. 32 can be divided by 2 nicely, and so we have ourselves 16 rad 2. We'll keep that as is for now. Okay, we'll worry about rounding at the very end. Because if you round in the beginning and you round like 2-3 times throughout the process, what ends up happening? You round it too much, and so your answer is not going to be very accurate. So on these questions, we're going to round at the very end. All right? So now with that we know what the side is, we have to think, well, how do I find the perimeter of a square? We got 4 congruent sides. How about we just take 4 times s? All right, we know what s is. It's 14 times rad 2. Oh no, I don't know what happened there. Things got moved around. Let me go back to the section that we need to be at, which is right here. And so we're going to go ahead and plug in 4 times 16 rad 2. So we go ahead and multiply that out, and then we get ourselves 64 rad 2. All right, if we round this to the nearest tenth, you got to plug that into your calculator right here. And oftentimes, I like seeing answers in simplest radical form, partially because a lot of answers and a lot of test questions later on will require you to do that. And so right here, it looks like we got ourselves 90.5, and then we talk about inches, and that is your perimeter. All right. So you're going to do the same thing with other problems throughout the chapter, whether they ask you to find the perimeter or the area. possibly of a triangle, square, rectangle, you name it. All right. So now you have all the equipment to get you through figuring out special right triangles. Know them. All right. This is another thing that you'll see on the PSAT and SATs quite often. All right. If you have any questions, let me know.